In this DeBacco University video, I'm going to go over the atomic theory of James Chadwick. All right, let's get into the atomic theory of James Chadwick here. So again, with any scientist, it's always important to have an idea of what was leading up to the development of their theory, because we're talking right around the year 1932. Discovery of the neutron is starting to come into play here. So remember, Rutherford's nuclear model in 1911 proposed atoms consisted of a dense positively charged nucleus surrounded by orbiting electrons. He later defined the proton in 1917 as a nucleus positive particle, but suspected additional neutral particles to account for the total nucleus's mass. And this is kind of where we're starting to see the continuation of that theory to then go through and be proven out. Thomson's electron discovery in 1897, who's identifying the electron, established atoms were divisible, setting the stage for future subatomic discoveries. Discrepancies in atomic mass. Again, scientists noted the atomic mass measured relative to hydrogen didn't align with the number of protons alone. So this concept, this idea, this theory of there's more than just protons. And then Rutherford's hypothesis hypothesized a neutral particle, dubbed it a neutron, to explain the mass discrepancy. And Chadwick, working under Rutherford at the Cavendish laboratory, set out to confirm this. So again, further proving these scientists were working together to develop these different ideas and concepts and refine one another's atomic theory. All right, so let's get into the discovery of that neutron. So Chadwick's discovery of the neutron. So neutron as a nuclear particle. Chadwick confirmed the existence of a neutral particle roughly equal in mass to the proton, about 1 atomic mass unit, meaning that the nucleus alongside protons. So they're basically residing together. They're basically found in a very similar physical location. And this helped explain the missing mass in atomic nuclei. So again, this concept here of this, we've got the protons are first identified, but then they're like, there's got to be something more. We're missing something. And that led to Chadwick to continue to refine research and find, essentially, and define the neutron. So a breakdown of his general atomic theory is that through experimental evidence, in his experience, he bombarded beryllium with alpha particles producing radiation that could eject protons from paraffin with significant energy. By analyzing the energy and momentum, he concluded the radiation consisted of neutral particles, neutrons, not gamma rays, as their behavior matched particles with mass, but no charge. So again, here's your beryllium, paraffin wax, alpha particle source, and then we've got our neutrons being discovered. Refined nuclear model is what led to this. After this discovery, Chadwick's neutron completed the picture of the nucleus composed of protons, which are positively charged, and neutrons neutral, with electrons, again, still orbiting around the outside. And this built on Rutherford's model, clarifying the nucleus composition and really further defining it. Again, we see kind of these atomic level, what's going on here with these detectors, with these alpha particle sources. Yeah, something's being released. Oh, it's not gamma rays. It behaves like a particle with mass, but it has no charge. Lo and behold, there we have the discovery of the neutron. So the mass and charge balance, so this again accounted for the nucleus's mass without affecting its charge, and this helped explain why helium, 2 protons, 2 neutrons, had an atomic mass of 4, but only a charge of positive 2. So again, we're having this filling in these observations we had, and now we're having some scientific inquiry to fill in those or define why those are. Also, this explained isotopes, because neutrons provide a mechanism for isotopes, which are atoms of the same element with different masses due to varying neutron count. So for example, carbon-12 with its 6 protons and 6 neutrons versus carbon-14 with 6 protons and 8 neutrons. So those isotopes have varying amounts of neutrons, which affecting its mass, but not the element identity or the charge of the element. So how does this kind of relate to the modern theory here? Well, nuclear structure. Modern theory describes a nucleus with protons and neutrons bound by a strong nuclear force, directly incorporating Chadwick's discovery. The electron behavior, the quantum orbitals replace Rutherford's orbits, in an area where Chadwick's work did not address. There's also nuclear interactions, and this modern theory explains nuclear stability via quantum chromodynamics, building on Chadwick's neutron to describe complex nuclear forces. There's also different applications where Chadwick's neutron is central to the modern nuclear physics, products, including reactors and medical isotopes, being used for all different aspects. So you can see that just neutron, while this subatomic particle of the atom may have no charge, it definitely has a strong influence and was discovered by Chadwick and is now an integral part of the modern theory.